All right, so we're going to go ahead and start, and Tanya's going to join us. Israel, where's your brother? Where's Demetrius? Okay, Israel's not even paying attention. All right, so we're going to solve systems of linear and quadratics. So everybody knows what a quadratic is, right? It's like a U-shaped graph. Yeah, go ahead. And a linear is a line. So good. The other thing is, Davina, since you're the only one that's here, make sure that you go into the webinar and just say attended so you don't have to do any of this. Okay, so we're going to talk about systems of equations. And these are both lines. So whenever we did systems, we had two ways to solve them. Okay, one way was graphing. Graphing is always the easiest way, and it's really simple if you have a graphing calculator because the graphing calculator can even find those intersecting points. So, in order to put it in the graph, into the calculator, you need to solve for y. So we took this top one and we just subtracted 2x from both sides. And then we took the bottom one and we subtracted x, and then divided through by a negative. And then just put them into the calculator, and this is the intersecting point. It is 6 and -4. So that's the easiest way to do them. And you can do these with the quadratics and the linear equations also. You can always graph them. Excuse me. All right, let's go. All right, the next method was called substitution. And substitution, again, you solve for y. You can solve one or both for y, and then just substitute in. So this is what we have for y. We're going to take that, -2x plus 8, and we're going to put it in there for y. Alrighty, and then after we do that, we're just going to solve for our x. So we'll add 8 to both sides and combine our 2x and x, and then divide by 3, and so we got x is 6. After we did that, we took this 6 and we put it back up here into the top and solved for y. So pretty easy stuff. And we get the same point, and that's good because if you didn't, then you had done something wrong. Okay, so 6 and -4. Last way, it's called elimination, and this one is more difficult because what you try to do is you try to find the opposite and the same coefficient, right? The opposite sign, same coefficient. So for our first method here, we could actually eliminate our y's. If we add them together, positive y, negative y is 0. Divide by 3 and we get x is 6. Then you can go and you can put it back in either one of these equations, it doesn't matter which, and solve for the other variable. Then you would divide by -1 or multiply both sides by -1. Either way would work. So, same point, thank goodness, because if you didn't get the same point, then you had done something wrong. Okay, so that's linear equations when they're both aligned. Oops, I don't want to do that. Okay, we're not going to try these, but if you did, you could graph them. If you graph them, you have to solve for y first. And these are your answers. Now, let's see. We have, so for our question that you guys don't have to answer because you're here, what I want you guys to do that are listening, I want you to solve equation 3. All right, so if you did not attend, your question is to solve equation 3 Wish I knew what slide this was. All right. So now we have two of these equations, right? This one is a quadratic. This one down here is going to be a line. I know this is a line because my x value on the second equation, the exponent is a 1. All right? So, solve. We're going to solve algebraically. And there are 3 questions on the assignment. And those questions are for you to solve this algebraically. So you can either, they're both set equal to each other. So they're both equal to y. So in this particular case, we're going to use some substitution. So where we see y, we're going to put x squared plus 1. Then we're going to factor, set each factor equal to 0, and these are the intersecting points, 0 and 1. All right. I'm sorry, those were the x values, and then we need to put both of those x values. All right, Israel. You put them in to this this equation, the top equation, because we used our bottom equation to solve for x. So when x is 0, y is 1. And when x is 1, y is 2. So there are 2 points of intersection, which, if you think about it, makes sense. Because what you have is a parabola, and that parabola opens up, and then you have a line, goes like this. So you have 2 intersecting points. All right. So most of the time you're going to have 2 intersecting points. When do you think you would only have 1 intersecting point? Remember, parabola looks, Parabola looks like this. When would I only have 1 intersecting point? Here's when I would have 2. This is my parabola. When would I only have 1? It can go both ways, but normally you would only have 1. That should only intersect it once. But when it just touches it on the outside, all right? Probably when it is at the vertex. All right. So let's try to solve this system algebraically. Again, we're going to use substitution. Okay, so our second equation, our linear equation, we're going to solve for y. Now this is going to look similar to the 3 problems that you have for practice 1, week 7. Okay. So we're going to have y. We have these 2 equations. So now we're going to set them equal to each other. All right? What we want to do is we want to get this equation, these 2 terms, over here with our squared term, and then we're going to factor. So we add 2 to both sides. Let me see here. Whoops, didn't want to do that. But we're going to add 2 here and add 2 here, and that's how we got the 4. And then we're going to subtract a 2x and subtract 2x. So that's how we get x squared minus 4x plus 4. Okay. And then we can factor. We want things that we multiply together to get positive 4, that when we add those 2 factors, we're going to get negative 2. All right? And it's x minus 2, x minus 2. So we're going to set each factor equal to 0. Since they're both the same, you only have to do this once, but, you know, if you like, you can do it twice. And we know that one of our intersecting points is going to be a 2, where x is equal to 2. So if x is 2, y is 2. So this is a case where it only intersects at one point. Okay?
So it only intersects when the points are the same?
No. Over here, you see how we solved for x and we got x is equal to 2?
Yeah.
And then what we take is that 2, and you can put it in either one of these equations and solve for y. So in this particular case, it was just that they were both the same.
Oh.
If you went back, oh, that's going to take forever. But if you go back to the other one, there were 2 intersecting points. X was 0 and y was 1, I think. And then x was 1 and y was 2. So there were 2 intersecting points with our last equation. Okay? All right. So this one, oh, I thought I got rid of this one. This one is a circle. This top one is a circle, and you don't really have to worry about this. This one's just fun. Yeah, I know you guys think, what kind of fun can you have? But, okay, so you can take the y is equal to x minus 6, right, and put it in there for y. Then just expand this out, so x minus 6 times x minus 6. You get x squared plus x squared minus 12x plus 36 equals 26. And put it all together. This one has a common factor of 2, so you can factor out that 2. Factors of 5 that add up to negative 6. And so what you have is x is equal to 5 and x is equal to 1. Now you're going to take both of these x values and you can put them into either one of these equations. Make it easy for yourself. You can even put it back here. Okay? Make it whatever's easiest for you to find the other point. So y is negative 1. So this is a case where you have 2 x values, so you have 2 y values. So what this is a circle, and this is a line through the circle, so that's why it intersects it twice. Okay? This is another one. It's just the same circle thing. And it's fun stuff. But in this case, I guess you could go through all of this. Again, you know, y is equal to 4/3 x. Solve this top one for y, right? Or no, I'm sorry, take this y and put it up there into y. Then expand this out. This is what you get. And you have x squared is equal to 16. So you guys know the square root of 16 is what? 4. But when you take the square root of something, you always do this plus or minus. All right? It's always the plus or minus. So when it's positive 4, y is 3. And when it's negative 4, y is negative 3. Okay, so if I were to graph this, oh, there we go. Hi, Jamie. What I would have is a circle. Now, these are 2 circles. I don't want to do this. Who did that? Sorry, guys. Here we have 2 circles, and it's just intersecting. Now we're going to look at some graphs. Okay? And this is one way that you guys can do this, but I want to see the algebra too. Okay? Yours that you're going to do with your practice of 3 fairly simple, like the first couple that we did. Okay? Classify these equations. So what's my top equation? What type of equation is it? Is it linear or is it quadratic? Quadratic, good. And the bottom one then is linear. All right. So what does the graph of each one look like? Top one looks like a parabola or a U, either one. And the bottom one obviously looks like a line. And so there's my parabola and there's my line. All right? So when you graph, the graphing calculators, and I think even the one online that you can use, Desmos, you can find these intersecting points. Okay, pretty straightforward. But make sure that you can do the algebra. Points of intersection. Okay, so we've solved algebraically. And now you can use your calculator to check them. And by using your calculator, you're just going to find the intersecting points. Okay? For the top one, it's at x equals 0, y equal 1, and then x equal 1, y equal 2. All right, bottom one, 2, 2. See how this, your answer here on your calculator is 1.99999 rounded up. Okay, that's, all right. And that is that. There's only 3 questions for the first practice. Pretty easy, pretty straightforward. Okay? Any questions? No? No? Questions over there, Israel? All right, where's D, Israel?